This lesson is a continuation of the notes that were given about two lines cut by a transversal, except today I'm going to kick it up a notch and we're going to deal with parallel lines that are cut by a transversal. Before I go there though, let's review the four types of angles that we talked about in those two lines cut by a transversal notes to make sure that we're good to go when we kick it into parallel lines. So an example of alternate interior angles, I'm talking about the inside of my two lines on opposite sides of the transversal. So if I'm using angle 3 and I'm looking at the opposite side of the transversal inside of the parallel lines, the angle that would correlate with angle 3 would be angle 7. So angle 3 and angle 7 are an example of alternate interior angles based on this picture. Similarly, if I talk about alternate exterior, now I'm talking about angles on the outside of the the outside of the two lines, and then on opposite sides of the transversal. So now let's say I'm going to deal with angle 1. Well, I need to be on the other side of the transversal, outside of the two lines, so I would need to deal with angle 5. Now I'm going to go back to dealing with inside angles, so same side interior would tell me that I'm dealing with, for example, angle 6 and angle 7 because they are on the same side of that transversal line inside of the two lines that we're discussing. And then corresponding angles, those are going to be angles that are in the same position of the transversal on either the top line or the bottom line. So if I deal with angle 4, it is on the top of the line on the left-hand side of the transversal. So when I look at the other line, I'm dealing with the top on the left of the transversal, so it would be angle 2. That would be corresponding to angle 4. I need to be successful in knowing what these types of angles are in order to be successful when I put these into parallel lines. So there's a couple theorems that we're going to deal with that deal with the four angles that we just discussed. The first one that we're going to look at is an alternate interior angle theorem. So now when I look at those alternate interior angles, if my two lines that I've been given are parallel, then I can say that the alternate interior angles are congruent. I'm just going to call these line L and line M to make our lives easier. And I'm going to call my transversal T. So in this case, if I was going to deal with alternate interior angles, these two arrows tell me that line L and line M are parallel. So I could say that angle 3 would be congruent to angle 5 because they are alternate interior angles on two parallel lines. The next theorem we're going to look at is alternate exterior angles. This is the same idea. So if I have two parallel lines, so here's line L and line M, these arrows tell me that they are parallel lines, and my transversal is T, then my alternate exterior angles are also congruent. So for example, if I'm talking about angle 1 would be congruent to angle 7. The next theorem that we're going to talk about is a same side interior angle theorem. Now this one is not congruent. These ones are supplementary. So if I'm talking about angle 3 and angle 6, for example, what I know is that whatever the measure of angle 3 is, plus the measure of angle 6, is going to put me at 180 degrees total. And then last but not least, I have a corresponding angle postulate. And this tells me that if I'm dealing with these same lines, L and M, that are parallel, and they are being cut or intersected by a transversal, then if I have corresponding angles, we are going to know that they are congruent. So if I was dealing with angle 2, angle 6 would also be congruent to angle 2. So I'm going to start using these theorems in order to actually solve problems where I've been given something like this. So in this case, they're going to tell me that angle A and angle B are parallel. If they don't give me the parallel notation on the lines, they have to tell me in word form. Otherwise, I can't assume anything. So since they told me A is parallel to B, I'm allowed to say that I can go ahead and use my knowledge of those 4 theorems I just gave you to try to solve this problem. Now, these are alternate angles. I'm sorry, these are exterior angles. But they're not alternate angles. They are on the same side. What we just wrote down, or the theorem that we just talked about alternate exterior angles, which these are not. So now I need to use my thinking cap. How can I relate 136 degrees with 2x in order for me to find the value of x? Well, if I use my knowledge of alternate exterior angles, 136 degrees would be congruent to this missing angle here. So I could say that this is 136 degrees. Now if you use your knowledge from the lesson that we did yesterday with different types of angles and supplementary and complementary and linear pairs, you'll notice that these 2 angles are a linear pair. So I'm putting together what we did yesterday with these theorems, and now I can see that 136 plus 2x has to be equal to 180 degrees. And now I can go through and start using my solving methods to get x by itself. So I would have that 2x was equal to 44. I'm going to move that out of the way. Which would tell me that x would end up being equal to 22. So if you have questions about this one, make sure you jot yourself a note in your margin of your notebook and ask me during class. Alright, so let's go to another example. Now this didn't give me any information in word form about the lines, but you can see here that it gave me that parallel notation, so I know I'm allowed to use all the theorems we just discussed earlier. These angles are same side interior angles, which tells me these are supplementary. So I need to take both of these angles, add them together, and set them equal to 180 degrees. So I'm going to say x plus 78 plus x plus 118 is equal to 180. And now from this point, I'm set up to start using my solving methods to get x by itself. I'm going to combine like terms first. So I had 2x plus 194 was equal to 180. Now you might start getting a little worried because you can see that when I subtract 194, I'm going to get negative 14. And that's okay because x does not represent an angle. X is a piece of my angle that I've been given. So the fact that x in this case ends up equaling negative 7 is okay because x is not the angle itself. When I plug x back in, or I substitute x back in into these 2 statements here, these 2 pieces of my angles, I'm going to be able to figure out what the angle actually is, but x isn't the angle itself. So I'm okay with x being negative. I'm not okay with an actual angle measurement being negative. All right, we have 2 more examples that we're going to do. In this case, my first mission is to figure out what types of angles I've been given. These angles, if you look, are on parallel lines, so I can start using the names that we've talked about in this video so far. This angle is on the top left of this first parallel line, as is 5x plus 8, so that tells me that these are corresponding. Since these are corresponding angles, I know that they're congruent, which means I can set those 2 expressions equal to each other. So I'll have 5 plus 8x equals 7x plus 16. And now I can go through and start solving for x. I'm going to subtract 7x first, which would give me 5 plus x equals 16. And then I'll subtract 5 and get that x is equal to 11. And again, x does not represent the actual angle measurement. It represents a piece of the expression. And the last example that we're going to do, this one is a little bit more complex. You'll notice that I have x's and y's in this picture. And that's okay, because they told me that these lines are parallel. So I can use all of the theorems that I already have in my pocket from what we discussed earlier. Now this one I am going to have to use my thinking cap, because the angles that are both labeled with x's don't necessarily have a relationship that we've talked about so far. These two, based on what we talked about yesterday, 4y minus 10 and 3x, these create a linear pair. So I know that these two are supplementary. They add up to 180 degrees. 4y minus 10 is the alternate exterior angle that relates to 9x plus 12. But again, that doesn't relate x's together. That related x and y. So I'm going to figure out a way to get 3x and 9x plus 12 to be related to each other. If I look at where 3x is in this picture, if I want to find a way to get 3x up here to relate with 9x plus 12, I'm going to think about either a corresponding angle, or since this is inside, I'm going to think about alternate interior. Either way, you're going to be able to get 3x on the top parallel line to relate it to 9x plus 12. So I'm going to do corresponding angles in this point, or in this situation, which tells me the corresponding angle here would be right next to 9x plus 12. Now I'm in a situation where I have a linear pair. So I can take 9x plus 12 and add it to 3x, and I know that that has to be equal to 180 degrees. Now I have an equation with only x's, which means I can go through and solve this. So I'm going to combine like terms, so that gives me 12x plus 12 equals 180. And then I'm going to subtract 12, and I'm going to divide by 12. So I'll have 12x is equal to 168. I'm going to make this a little bit larger. Or x is equal to 14. Now I've got x. Now I'm at a point where I can start dealing with y, because I already have gone and figured out what x is equal to. Two different ways you could go about this. You could look at 4y minus 10 and 3x being a linear pair, which means I would add these two together and set them equal to 180, just like I did here. I'm going to look at it in relationship to 9x plus 12, because I know that 4y minus 10 and 9x plus 12 are alternate exterior angles, which tells me that they are congruent. So I can say that 9x plus 12 is equal to 4y minus 10. I'm going to kind of make myself a little space here. But I already know what x is, so I can say that 9 times 14 plus 12 is equal to 4y minus 10. If you simplify this statement here, this ends up being 138, and that's going to be equal to 4y minus 10. Add 10, so I have 148 is equal to 4y. And last step, I'm going to divide by 4. So I have that y is equal to 37. If you have any questions about anything I talked about in this video today, please make sure that you make a note of it in your notebook, in your margin, and bring it back to me in class.